Spanning tree RootGuard is a security-related spanning tree enhancement from Cisco. The purpose of this feature is to protect our switch topology from the rogue root switches. The rogue root switches are the switches that are sending superior BPDUs, and the definition of the superior BPDU can be many things. One, it's a BPDU that has the lower priority or the MAC address than the current root. Or it's a BPDU that is coming from the same root but is being received on the designated port of the local switch, and it claims to have a better root path cost than our own port. When the RootGuard is enabled on the port, it is enabled for all the VLANs, and this is the only way to configure the RootGuard. It can be enabled only on per port basis for all the VLANs on that port. When a superior BPDU is received on a port with the RootGuard enabled, what is going to happen is that this port is going to be moved into a spanning tree root inconsistent state. This is a special state that doesn't exist in the standard definition of the spanning tree, and in this state the local port will still be sending the local BPDUs, but all the traffic coming in on that port and all the BPDUs received on that port are going to be ignored if they are superior to our own local copy of the best BPDU. This state can be easily cleared from the port if we simply stop receiving the superior BPDUs from another switch. Let me give you an example of all this. Let's imagine a network consisting of 3 switches: our Cat1, Cat2, and Cat3. Let's say that Cat1 and Cat2 are the core switches in our network, and they have a high-speed interconnection of 1 gigabit per second. So this is gigabit 01 and this is gigabit 01. Now let's say that Cat3 here is either an access switch or it may be a distribution switch. But let's keep it simple. Let's say that it is an access switch, and it has dual uplinks to both Cat1 and Cat2, but these uplinks are a little bit slower. So these are going to be the fast Ethernet links. So this is going to be fast Ethernet 22, and this is going to be fast Ethernet 22 here. This is fast Ethernet 20, and this is fast Ethernet 20. In this network here, let's say that the majority of hosts are behind Cat1 and Cat2. So these are some hosts here and some hosts here, large number of these hosts here. And let's say that behind Cat3, I just have a few hosts. In this network as it is, the preferred topology is to have a gigabit link here in a forwarding state and one of 2 links between Cat3 and Cat1 or Cat2 forwarding and the other one blocking. So let's say that this is the topology that we want to have. If we want this topology here, we need to ensure that Cat1 is the root, we need to ensure that Cat2 here is the secondary root or the backup root for Cat1, and we need to ensure that Cat3 is the least likely to become the root. But what would happen in this network if Cat3 would be configured to be the root, if it simply claims to be the root? Well, what will happen is it will start sending superior BPDUs. It will send a superior BPDU to Cat1, it would send the superior BPDU to Cat2, even though this port here is blocking. The BPDUs received from Cat1 sent to Cat2 and then from Cat2 to Cat3 are going to be inferior to our own local copy, which means that Cat3 is going to determine that it has won the root election, and it's going to simply start sending its own copy of the BPDU towards Cat2, even though this was a blocking port in the original topology. When this happens, Cat2 here is going to determine that it needs to recalculate its spanning tree. The same thing is going to happen on Cat1. So if Cat3 claims to be the root, the resulting spanning tree topology is going to look like this. So I'm going to have Cat1, Cat2, Cat3. Remember, this here is the gigabit link, this here is the fast Ethernet link, and this here is the fast Ethernet link. But the actual active topology is going to be like this. And what's going to happen most likely is that this becomes the designated port and this becomes the blocking port. And given the fact that vast majority of hosts are sitting behind Cat1 and Cat2, we can no longer use the high-speed link between them, and instead we actually need to send the traffic over the slow links between Cat1, Cat3, and Cat3 and Cat2. This is clearly an undesirable situation, but in traditional spanning tree, there is really nothing we can do about this, because there is no authentication in the spanning tree, there is no encryption, there is no protection of any sorts. And this is pretty much the situation that RootGuard was designed to solve. So how can we use the RootGuard to solve this particular problem? Let's take a look. I'm going to start by redrawing the network diagram. So I have Cat1, I have Cat2, and I have